Hello. In today's lab, we will use the law of conservation of energy to measure a value for acceleration due to gravity. I want you to watch the experimental setup I have done. I have a lead ball that is at a certain height from the top of the bench. I can raise it to a measurable height. Now you can see I have arranged a ruler here, and now the height of the ball now is 10 centimeters from its initial position. If this is 0, if you watch my meter rule here, this is the 0 of the meter rule. This 0 of the meter rule is exactly at the same level with the center of the ball. So when I raise the ball and touch the 10 centimeter mark, there is the 10 centimeter mark. Now the ball has been raised through a height of 10 centimeter. Alright, this is our variable, one variable we call h. I want you to measure this. Alright, measure the distance from the tip of the ruler to the center of the bob up to here, and its actual value is 10 centimeter. Now divide this 10 centimeter by the measurement you have, and that is the conversion factor. Now as I raise the ball higher and higher, you must be able to measure the height of the ball on the screen and multiply it with the conversion factor. Alright, so do the conversion factor now. Measure this height, that is from the tip of the ruler to where I'm pointing. You need to measure that distance. Then the actual distance is 10 centimeter. So divide the 10 centimeter by the distance you measure. That is your conversion factor. Alright? Okay. Now once you raise it to this height, you can see the initial position of the ball is here. We will assume that its potential energy there is 0 and its kinetic energy also is 0. When you raise it to a height h, you are giving it potential energy. So the mass now has potential energy. If you leave this, we would expect that all this potential energy will become kinetic energy when it comes back to the original position. And we can measure the velocity of the ball. Now you are familiar with the use of the photo gate. Now when the ball passes through the photo gate, the diameter of the ball will block the beam of light. Now the diameter of the ball is then the distance traveled by the ball, delta x. And during the time during which the ball blocks the light will be measured by this clock. And once you have delta x, that will not change, and measure delta t from the clock, the velocity will be therefore delta x divided by delta t. And that will give you the instantaneous velocity there. And now we have, when the ball is raised through a height h, it has potential energy. Now the potential energy is mgh. When you let the ball go, this is what we will do. We will raise it to the height h, and then we will let it go. Now all that potential energy will become kinetic energy there, and by measuring the velocity we can calculate that kinetic energy. So we will be able to say mgh equal to 1/2 m V squared. Now m and m on either side will cancel. We have GH equal to 1/2 of V squared. Well, tell me, what are the variables here? The variables are H and V. You change H and V also changes with the value of H. So, since V is the dependent variable, I can write it like this: V squared equal to 2GH. That means this is now of the form y equal to mx. So if you plot a graph of V squared on the y-axis and H on the x-axis, the slope of that graph will be 2g. Alright, now you will be able to obtain a fairly good value of g from here. Okay, so what are the values that you are going to measure? I'm going to change h values. So you will measure the h values. You have the conversion factor. Remember the initial position is here. So you will start your measurement from this position of the ruler. So measure h each time I repeat the experiment. And then I will raise the ball to the whatever h value we have, and then I'll leave it. You need to measure the time from the clock and calculate the instantaneous velocity. So your table will contain, I want you to make your own tables. What are the values that will have? H will be measured in meters, then delta t, then your V equal to delta x divided by delta t, and then of course V squared, because you're going to plot a graph of V squared on the y-axis and h on the x-axis. Now when you write these quantities, I want to see all the proper units. Delta t, what's the unit? V, what's the unit? What is the unit of V squared? Well, if you know the unit of V, you know the unit of V squared. Alright, so make your tables and plot your graph, obtain the value of G. Let's do the experiment. For the first trial, alright, I'm going to raise the ball to a height h. This is now a height h. I'm going to turn on the clock. Alright, reset it. And now, what is this h value? I gave it to you. This is 10 centimeter. Alright, and you have measured it. Okay, I'm going to leave it, measure the value of delta t. Now, what is the value of delta t? Delta t is 0.0029, I think. Is that right? 0.0029. Now, I'm going to do that one more time, or I'm going to do it 3 times. So, each measurement we take 3 times, 3 trials, and then take the average. Okay. So let me reset that clock, move the mouse away, reset the clock. I'm going to put that one more time at height h. Alright, height h equal to 10 centimeter. There we are. Let's go. Measure the time. 0.0027 this time. The first value was not 0.00. Remember, the clock is red. The first 2 zeros are whole numbers there. Is that right? So that will be 0.027, not 0.00. I hope you are able to read the clock correctly. All right. Now the clock reads like this, 00 point. This is the decimal point. So this is 0.027. Your first reading was 0.028. Alright, let's do a third trial. Reset the clock. I raise it again to the 10 centimeter mark. That is my H value. And I'm going to leave it. There we go. What is the time now? 0.0026. Alright, you got 3 values of time. And now find the average of that and calculate the instantaneous velocity for that data. Okay. And now I'm going to raise the ball to a new height. I want you to measure that height. Okay, this is the new height. That means you need to measure the distance from this point to this point over here where I'm pointing. Well, let me point that out for you. This is the point where you will measure the distance from here, bottom to here. Measure that distance multiplied by the conversion factor. Alright, reset your time and let it go. What is the time? It's 0.022. Okay, let's do the second trial. The H value, the second H value. Okay, let's go. 0.0223. That's the second trial. Let's try one more time at the same H value. Reset. Let's go. Alright, you got now 3 time values for that H. Let's now change the H value. I'm going to change it to a new value. You need to measure it. Alright, I have a new H value. Are you ready? Alright, our first trial from our third H value. I hope you have finished measuring. Okay, I'm going to give you some more time. You measure it from this point to here. Alright, that's the center of the ball. Okay, and I'm going to leave it. There it goes. The time is 0.019. Okay, I'm going to repeat that one more time. The second trial. Reset the clock. And there it goes. 0.019 again. Now read it to 3 decimal places. Alright, one more trial. Reset. And go. 0.019 again. Okay, now the next trial. This was the third, isn't it? Let's go to the fourth trial. I'm going to increase H again. I need my glasses there. Okay, I have now the new H value. Measure that height. Measure the height from where I'm pointing to this point. Measure that height on your screen and multiply it with the conversion factor. And let's go. I'm going to reset it. There it goes. That's 0.017. Let me do that one more trial. Alright, the second trial. There you go. 0.0171. Keep all the 3 figures so that you get very accurate values. Alright, reset it. The third trial, go. That's again 0.0172. We got 3 trials for that H value. Now let's increase the H one more time. Into my glasses. Alright, I have now increased the H value and I'm ready. Let's reset the clock. Alright, let's let it go. There it goes. And the time is 0.0156. Alright, keep all the 3 figures. Second trial. Again 0.0156. The third trial. I hadn't reset the clock. Reset it. Let's do the third trial. .0156. Well, we are now ready to increase H by another value. Let's increase H. Okay. Now this is now the new H. Measure that distance. Measure the distance from the bottom of the ruler to the center of the bob. Okay, I'm going to wait for you to measure that distance. Measure that height. Alright, let's do the first trial. Reset the clock and do the first trial. There we go. 0.0146. Let's try that one more time. Okay, let it go. I hadn't reset, did I? Okay, let's do the second trial. Go. 0.0145. Third trial. Okay, it's 0.0141. Ready for the next height? Okay, I'm going to move to the next height. Alright, now measure that height. Measure the height from here. I hope you can now see. Well, let me bring that background so to make it a little more easy for you to measure. Is that right? Now, your measurement must be from the bottom of the ruler to, well, over here. Oops. Well, I'm back in business after the little disaster I had. Did you measure that height? This height. There you are. From the bottom of the ruler to here, up to where I'm pointing. That's a new height. Okay. And I'm going to leave it, reset the clock, and there we go. The height is 0.0134. Let's do that a couple more times. Reset. There we go. 0.0136. Is that right? Alright. Let's reset it and let it go again. There you are. Read the 3 times and obtain the average and calculate the instantaneous velocity. Okay, let's now move to the next height. Okay, I'm now going to take the ruler to that height. Okay, I want you to measure the height. Can you now see this? Measure the height from the bottom of the ruler to here where I have the center of the bob. Alright, that's the height. Measure it and multiply it with the conversion factor. Okay, there we go. The clock is ready to read. Okay, let's go. There we go. 0.0127, I think. But you're supposed to read it. I'm not supposed to read it, actually. Second trial. There we are. The third trial. There we go. Okay. We got 3 trials on that height. And let's now go to the next height. Okay, let's now do the next height. Okay, this time the height is measured from the bottom to here where I'm pointing. You need to measure that height. Okay, let's let it go. First trial. 0.0122. You see how important it is to read those 3 digits, because the previous height we had 0.0127, so this is 122. Okay, the second trial on this height. The second trial, let's go. That's 0.0119. Let's do one more trial on that height. Okay, that's 0.0121. Find the average of those and find the instantaneous velocity there. Okay, let's see if I can take you to another height. Alright, there, another height. And now measure this height. Right, the height from this point to the center of the bob. Now I think you have gone out of screen. Let me adjust the camera for you. So this time you measure the height from this point to here. There you are. That's the point where the center of the bob to here. Okay. Measure that height and I'm going to let it go. Okay. Let's see. Hits nothing. There it is. What is the time? 0.0115. Alright, let's take another trial. Okay. Reset. Let's go. 0.0114. Let's do another trial. Let go. There you go. 0.0114. I'm going to try one more height. Okay, let's see if that is going to be possible. There you go. Can you see this? That is the position. I think you can barely make it. Is that right? Okay. And measure the height from the bottom here, you can see that, to the middle of this. That's up to here. There you are. Okay. And now, let's see if it gives you any meaningful result. Let it go. There we go. 0.0113. Let's try one more. Second trial. There we go. 0.0109. Alright, that looks good. One more trial from this height. Let's see if it's going to work. Alright, let it go. There we are. Okay, that's 0.011. Alright, now we have, I think, about 11 heights. We got 11 height values and the corresponding velocity values. You plot your graph, v squared on the y-axis, h on the x-axis, measure the slope and obtain a value for g. Okay.